something ancient began to crawl. It has watched the world end 5 times. Think about that. 5 separate apocalypses. You see, when the first primitive fish were just evolving, this creature was already here. It survived the Ordovician Silurian extinction, a planetary deep freeze that wiped out 85% of sea life. It swam through the late Devonian extinction when the oceans were choked of oxygen. It endured the Great Dying, the Permian extinction, an event so violent it annihilated 96% of all species on Earth. It was a footnote. It saw the asteroid that killed the dinosaurs and simply kept crawling. They call it the horseshoe crab. But it's not a crab at all. It's more closely related to spiders and scorpions, a living fossil, unchanged for hundreds of millions of years. It looks like something from another world. A bronze armored dome, a dozen eyes scattered across its shell, some that can see ultraviolet light, a long, sharp tail, a telson used to right itself if flipped by the waves. It is a masterpiece of survival. But its greatest secret isn't its armor. It's not its 10 legs or its ancient design. It's what flows through its veins. And here's where the story gets strange. Its blood is not red. It's a shocking electric blue. This is due to hemocyanin, a copper-based protein that carries oxygen. But the color is just the beginning. That blue blood contains something priceless, a unique clotting agent called Limulus amoebocyte lysate, or LAL. This substance is the most sensitive detector of bacterial toxins known to science. It is our frontline defense against contamination. Every vaccine you've ever had, every intravenous drug, every surgical implant inside a human body was first declared safe by the blood of this creature. The official reports state the annual harvest is sustainable, that the animals are bled and carefully returned to the sea. But some scientists disagree. They point to mortality rates as high as 30%. They point to disoriented survivors unable to breed. The very immune system that allowed it to witness 5 mass extinctions is now the target of a global, multi-billion-dollar industry. It survived asteroids and ice ages. It outlasted monsters and planetary cataclysms. But what happens to us when the last apocalypse witness finally dies? The answer begins not in the future, but in 1956 at the Woods Hole Marine Biological Laboratory in Massachusetts. A scientist named Frederick Bang was not trying to save humanity. He was simply curious. He wanted to understand how this ancient creature fought off infection. So he took a syringe filled with common seawater bacteria and injected it directly into a horseshoe crab. What he saw next changed modern medicine forever. The blood did not just clot, it transformed. Within seconds, it became a solid gel, a semi-solid prison, perfectly encasing every single bacterium. He had stumbled upon one of the most powerful immune systems on the planet. Think about what that means for you. Your own immune system sends out cells to fight invaders. This creature's blood builds a wall around them. Instantly. The substance responsible is called Limulus amoebocyte lysate, LAL, and it reacts to one thing with absolute, unerring precision: endotoxins. Endotoxins are the toxic skeletons left behind by certain bacteria. They are invisible, they survive sterilization, and even in microscopic amounts, they can trigger fever, septic shock, and death if they enter your bloodstream. The official textbooks don't linger on this part. Before LAL, the only way to test a new drug for these toxins was called the rabbit pyrogen test. Scientists would inject a batch of medicine into a row of live rabbits. And wait. They would watch the animals, taking their temperature for hours to see if they sickened. It was expensive, and it wasn't nearly sensitive enough. But Frederick Bang's discovery offered a way out. A simple, elegant test. Mix a drop of a drug with the crab's blue blood extract. If it remains liquid, it's pure. If it turns to gel, it's contaminated. And here's where the rush began. By the 1970s, the FDA had approved the LAL test. Suddenly, that electric blue blood was worth more than gold. A global industry was born. Each spring along the Atlantic coast, the harvest begins. Boats dredge the shallow waters, pulling up hundreds of thousands of these living fossils. They are brought to sterile labs where they are mounted, still alive, onto racks. A needle is carefully inserted through a joint in their shell, directly into the tissue surrounding their heart. For the next 24 to 72 hours, about 30% of their blood is drained away into a sterile bottle. The official story, the one you'll find in industry pamphlets, is a gentle one. They say the crabs are then returned to the ocean, that mortality rates are low, perhaps only 3%. But some biologists who have studied this process tell a different story. The documents they've published paint a much darker picture. Independent studies from the University of New Hampshire and Plymouth State University found post-bleeding mortality rates as high as 30%. 1 in 3 may not survive the ordeal, and nobody ever talks about the survivors. Even those returned to the sea are often weakened, disoriented, and less likely to spawn. Their ancient rhythm is broken. This has a catastrophic ripple effect. An entire species, a shorebird called the red knot, has timed its 9,000-mile migration to arrive at Delaware Bay precisely when the crabs are laying their eggs. And they feast on the eggs to refuel for the final leg of their journey. But with fewer crabs spawning, the feast is vanishing. The red knot population has crashed by over 75%. An entire ecosystem is being starved. And all of this is done in the name of human safety. A necessary sacrifice, we're told. But here's the part that's almost never mentioned. In 1997, scientists at the National University of Singapore created a synthetic alternative. It's called recombinant factor C. It's made in a lab. It performs the exact same function as the crab's blood, without harming a single animal. It has been available for more than 25 years. So if a perfect humane substitute exists, why are hundreds of thousands of these ancient survivors still being bled every single year? Why continue to bleed an ancient creature when a perfect synthetic substitute has existed since 1997? The answer isn't found in a laboratory. It's found in a ledger, and on the letterheads of powerful regulatory bodies. Think about this. A single quart of processed horseshoe crab blood, the Limulus amoebocyte lysate, can be worth over $15,000. The global LAL industry is a machine that generates hundreds of millions of dollars every year. You don't just shut down a machine like that. You protect it. The primary gatekeeper for drug safety in the United States is an organization called the United States Pharmacopeia, or USP. For nearly 50 years, their official rule book for testing bacterial toxins had only one approved method: the blood of the crab. To get a new method approved is not a scientific challenge. It's a bureaucratic war, and here's where the fight began. By the early 2000s, some pharmaceutical companies like Eli Lilly began the long, expensive process of validating the synthetic recombinant factor C for their own products. They spent years and millions proving it was just as good, if not better. They succeeded. But that was for one company, for one drug. What about the thousands of others? The system was designed to favor the old way. It was designed for inertia. But then things started to change. In 2016, the European Pharmacopoeia officially recognized the synthetic as an established alternative. The pressure mounted. Finally, in early 2020, it looked like the American system would follow. The USP proposed a new guideline that would remove the biggest hurdle, on making it much easier for any company to switch from crab blood to the synthetic. The door was finally opening. And then, just months later, it was slammed shut. In a stunning reversal, the USP withdrew its proposal. The official statement cited a lack of stakeholder consensus and insufficient supporting data. Read that again. Insufficient data for a technology that had been used safely in medicine for over 2 decades. So what really happened? The public records on the proposal tell a different story. The world's largest LAL manufacturers, corporations like Charles River Laboratories and Associates of Cape Cod, lobbiedly against the change. They submitted comments sowing doubt, questioning the synthetic's reliability. The very companies whose profits depend on the annual harvest were advising the gatekeepers on whether to end it. No one seems to ask the obvious question: how can you trust the purity of a product harvested from a wild animal? An animal dredged from coastal waters increasingly filled with industrial runoff, agricultural chemicals, and microplastics. And here is the part that is almost never discussed in the official reports. The LAL test is a biological marvel, but it has a massive blind spot. It is incredibly specific, reacting only to endotoxins from a certain class of bacteria called gram-negative bacteria. It is completely blind to toxins from gram-positive bacteria. It is blind to fungal contaminants. It is blind to viruses. Think about what that means. Our entire global infrastructure for sterile medicine, the system that protects billions of people, is built on a test that is looking for only one specific type of threat. Now, we have built our fortress to defend against arrows in an age of bullets. The synthetic RFC is different. It is manufactured in a completely sterile, controlled environment. Every batch is identical, pure, predictable. The blood of the crab is not. It comes from the wild. We are using a living fossil to guarantee the purity of our most advanced, sterile medicines. And we never stop to ask the most important question: what if the witness itself is becoming contaminated? The irony is terrifying. In our effort to protect ourselves from invisible poisons in our medicines, we may belie introducing a far more patient poison directly into the heart of our medical system. Patient poison isn't a hypothetical threat. It's a question of time. For decades, the system that keeps your medicine safe has relied on a single, wild source, a source now showing signs of collapse. And here's where the story stops being about regulations and corporate memos and becomes about people. People like Glenn Govry. In the 1990s, Govry worked for a company that manufactured components for the biomedical industry. He was part of the machine. He understood the process. But then he began walking the beaches of Delaware Bay during the annual spring spawn. He saw something the industry reports never mention. He saw the bodies. Thousands of horseshoe crabs, weakened and disoriented after being bled, were washing ashore, unable to right themselves, helpless. Imagine seeing that. An ancient ritual of life, ice spanning 450 million years, turned into a mass graveyard. The tide comes in, and they are trapped. The gulls descend. So, in 1999, Govry started a simple program. He called it Just flip 'em. The idea was elemental. If you see a crab stranded upside down on the beach, you just flip it over. You give it a chance. That small act of intervention became a quiet rebellion. A network of volunteers walking the shoreline, hour after hour, searching for the overturned. It was a direct response to a system that saw these creatures not as ancient life, but as living factories. And it wasn't just the crabs that were suffering. Someone else was watching the same tides with a growing sense of dread. Dr. Larry Niles, a biologist, has spent more than 25 years on these beaches. His job? Counting a bird. The red knot? Think about that. And your entire life's work is to count something that is disappearing right before your eyes. He described the early years as a spectacle of nature. Millions of horseshoe crab eggs, a moving carpet of life that fueled the birds on their 9,000-mile migration. Now, he says, there are beaches with no eggs at all. The silence is what's terrifying. The red knot population has crashed by over 75%. We talk about extinction as some distant, abstract concept. Dr. Niles watches it happen in real time, season after season. So you have Glenn Govry flipping crabs one by one. You have Larry Niles counting birds that are no longer there. These are not radical activists. They are witnesses. They are trying to repay a debt we didn't even know we had. Every person alive today who has received a vaccine, an IV drip, or a prosthetic hip owes their safety to this one creature. Read that sentence again. Every single one of us. The blood that protected this animal from 5 mass extinctions has been protecting you your entire life. The system that bleeds them is justified as a necessary sacrifice for human health. A trade-off. But what the official reports never calculate is the cost of breaking a 450 million-year-old chain. We have taken its ancient defense. We have taken its future. We have taken the food from the mouths of starving birds. Now, a 6th extinction is underway. This time, it's not an asteroid or an ice age. It's us. And after taking so much from this silent witness, what happens when it finally needs something from us and we have nothing left to give? And we have nothing left to give. That moment is not in the future. It is now. The horseshoe crab isn't just asking us to stop. It's asking for a world it can still recognize. Because a new threat is gathering, one that no amount of blue blood can protect it from. You see, for 450 million years, this creature has adapted to change, but never at this speed. The oceans are warming faster now than at any point since the last ice age ended. At the same time, they are becoming more acidic. Think about what that means for a creature with a shell. The very water it breathes is turning corrosive, interfering with the development of its larvae. It survived asteroids that vaporized the seas, but it may not survive our atmosphere. And here's the part nobody likes to confront. On the biomedical bleeding is a problem we can solve. The synthetic substitute exists. The switch is a matter of paperwork and will. This is different. This crisis is written into the very engine of our world, and yet, hope is not extinct. Remember recombinant factor C, the synthetic blood? In 2023, after decades of resistance, the United States Pharmacopeia finally gave it equal standing to the crab's blood. The bureaucratic war easily being won. Major pharmaceutical companies are making the switch. Not because they are forced to, but because it is better, more reliable, and more humane. The change is happening, not with a bang, but with the stroke of a pen in a laboratory logbook. And on the beaches, people are still walking. Volunteers are still searching the tide line. still flipping them over, one by one. It's a small act, almost absurd against the scale of the problem. But it is not nothing. It is a refusal to be a bystander. It is a vote for survival. This creature is a living message from a time before flowers, before birds, before the continents we know even existed. It is a testament to the idea that what endures is not brute strength, but the ability to adapt, to carry on. It has been the keeper of the Earth's oldest story, the story of resilience. We have become the final chapter in that story, an unpredictable, violent, and powerful force. The question is no longer whether we can save the horseshoe crab. The real question is what saving it says about us. It has watched 5 worlds end, and